What if every sound you've ever made, your voice, your laugh, your music, could reach the stars? What if the emptiness of space wasn't silent, but filled with the same noise we live in here on Earth? Would space be the quiet, mysterious place we imagine, or would it be something else entirely? Let's talk about sound and space. Not in a science fiction kind of way, but in the real way that brings science and imagination together. Right now, we live in a noisy world. You talk, you sing, traffic passes by, the wind rustles through trees, and your phone buzzes. All that is possible because of one thing: air. Air is full of atoms and molecules, and they're the reason sound works the way it does. Your voice doesn't just float out of your mouth and into someone else's ears. It moves because tiny air particles are bumping into each other, passing that vibration along like a chain reaction. If you've ever stretched out a slinky and tapped one end, you've seen how a wave moves. That's pretty much how sound travels. It's a compression wave. You push one molecule, it hits the next, and so on. That's how your voice carries. That's how music works. That's how everything you hear exists. But space doesn't play by those rules. Out there, outside Earth's atmosphere, there's almost nothing: no air, no wind, no molecules to push sound around. And that's why, in reality, space is silent. Totally, completely silent. If you screamed outside your spacecraft, no one would hear you. Not because you're quiet, but because there's nothing to carry your voice. You could yell as loud as you want, and all that sound would just stop at your lips. But what if that wasn't the case? What if sound could travel through space? Let's say somehow the vacuum of space was filled with just enough particles to carry sound waves. Not packed like Earth's atmosphere, but enough that voices, engines, explosions, even whispers could move from one point to another. Everything would change. For starters, the idea of silent space would disappear. We'd hear the humming of rocket engines across the void. You could stand on the moon, radio off, and hear a friend shout from across the crater. Massive cosmic events like supernovas or colliding stars might not just be seen but heard. The universe would no longer be a quiet place. It would be filled with echoes. But let's pause right there. This brings up a real question. How would that even work? Here on Earth, sound moves at about 760 miles per hour or 1,223 kilometers per hour through air. That's faster than most planes fly. In water, it moves faster because the molecules are closer together. In steel, it's even quicker. But in space? Right now, space is a near-perfect vacuum. That means there are only a few stray atoms drifting around. In fact, in the space just beyond Earth, there are only about 5 particles in a space the size of a sugar cube. In the areas between stars, it's more like 0.1 particles per sugar cube-sized volume. And in the massive voids between galaxies, it's nearly nothing. That's why, today, sound waves can't move through space. There's just no chain reaction of particles for the wave to ride. But let's say that changes. Let's say there's enough matter floating around that sound can actually move. You'd need a lot more atoms, not as many as on Earth maybe, but enough for compression waves to pass along. Then sound would become something space travelers have to deal with. It would affect engineering, communication, even personal safety. Because sound isn't just about hearing, it's about energy. If engines make noise, that means they're vibrating. If explosions create pressure waves, those waves could shake ships or damage gear. Right now, astronauts live in this silent zone where danger doesn't come with a warning sound. But in a space where sound moves, maybe you'd hear the approach of a meteor. Maybe you'd hear the solar wind rustling through the outer walls of your station. Maybe space wouldn't feel so lonely. There's another thing. If sound could move through space, it would mean space wasn't as empty anymore. And that leads to something big. If you were exposed to that kind of environment outside your spacecraft without a suit, you wouldn't just be in a vacuum. You'd be in something denser, something like thin air. That changes everything. Right now, if you were caught outside in space without protection, your lungs would literally rupture. The air inside you is at a much higher pressure than the vacuum outside. It would try to escape all at once. In just 10 to 15 seconds, you'd lose consciousness. That's not because of cold or lack of pressure alone, but because there's nothing out there to hold the air in your body in place. That's the harsh truth about the vacuum of space. But if space wasn't a vacuum anymore, if it was filled with particles, you might survive a few seconds longer. Maybe longer than that. It wouldn't be safe, not by a long shot, but it wouldn't be instant death the way it is now. The danger would shift. Now you'd worry about what those sound waves could do. Explosions in space could shake spacecraft. Nearby collisions could send shockwaves through your ship's hull. Sound wouldn't just be a nice thing, it could be a real problem. It's also worth asking, what would the universe sound like? Because even now, in our soundless universe, something incredible is happening. In 2022, NASA released audio from a massive black hole in the Perseus galaxy cluster 250 million light-years away. Of course, black holes don't make sound in the usual way, but the area around them, the plasma swirling in their gravity, can ripple. These ripples are like ultra-low sound waves. The twist: they're 57 octaves below middle C. That's so low humans can't hear them. But NASA raised the frequency to make it audible. And what came out was something like a growl, a haunting rumble, a black hole making a kind of music through space. That brings us to another cool thing: plasma. In space, the tiny bits of matter that do exist are usually in this strange state. Plasma is a gas where electrons have broken away from atoms, creating a mix of charged particles. And in plasma, sound waves can act really differently. They travel faster. Their wavelengths are longer. They don't sound like anything you hear on Earth. They're more like signals or pulses. This is real science. Plasma waves in space can technically carry pressure variations that are similar to sound, just not in the way your ears would pick up. But if space were thick enough, if those plasma waves became dense enough to reach our ears, it would change the way we explore the stars. We wouldn't just see the universe, we'd hear it. You know what's even wilder? If sound could travel through space, the loudest thing in your life wouldn't be cars or planes or even fireworks, it would be the sun. You'd wake up every morning not to birdsong, but to a deep, endless roar, like standing beside a waterfall that never ends. And it wouldn't just be noise, it'd be everywhere. Because the sun, it turns out, is ridiculously loud. Craig DeForest, a heliophysicist who studies the sun, once did a rough calculation on what it would actually sound like if that noise could reach Earth, and he didn't hold back. He said the sun would be like 10,000 Earths, each one completely covered in screaming police sirens. That's not just a poetic image, it's real numbers. Each of the sun's convection cells, those massive blobs of gas bubbling up from below the surface, are about the size of Texas. 1 million of them moving at once, rising, burning, falling and repeating, all within minutes. That process would shake the sun with constant explosions of pressure and energy. It'd make a deafening low roar, thick with sound from every frequency, like standing next to Niagara Falls but louder. A constant wall of sound. And yeah, we're 92 million miles away. But even at that distance, if sound could survive the trip, we'd be getting hit with around 100 decibels during the day. That's just under a rock concert, loud enough that conversations would be a struggle. You'd get a break at night when your side of the planet turned away, but still, every morning, the roar would come back. And here's another twist. Planets already have their own sound. If you could talk on Mars, your voice would sound weird. Thin air means high-pitched, tinny speech, like a piccolo. But on Venus, with its thick, hot atmosphere, your voice would boom deep and low, more like a bass guitar. That's because sound changes with the pressure and density of the atmosphere. The thicker it is, the slower the wave moves, and the lower your voice sounds. On Mars, the opposite is true. The thin atmosphere means higher-pitched sounds. Scientists have actually simulated these effects, figuring out what a human voice would sound like across the solar system. So if sound could move through the vacuum of space, If the space between stars and planets was just a little more dense, it wouldn't just be our voices that would change. Everything would sound different. We'd hear the differences between planets. We'd hear the textures of the universe. And that would change how we think about the cosmos. But there's a reason we don't live in that universe. The silence of space serves a purpose. It's the silence that allows radio signals to travel far. It's the silence that keeps our instruments safe from vibrations. It's the silence that lets us explore, without the chaos that constant sound would bring. And yet, in that same silence, we've learned how to listen not with ears, but with machines that pick up waves and frequencies we could never detect ourselves. Even though you can't hear sound in space the way you hear it on Earth, scientists are still listening. They listen to the plasma around stars. They listen to the ripples around black holes. They simulate voices on alien worlds. And they keep wondering, what would it really be like if we could hear the universe? Maybe it wouldn't be peaceful. Maybe it would be loud, messy, full of signals and noise and overlapping waves. Maybe sound in space would create more problems than it solves. But it does make you think, how much do we take for granted just because we can hear it here on Earth? Your voice, your favorite song, the sound of someone you care about laughing in the next room. Sound is so normal to us, we forget it's rare. Unique, even. A kind of gift from this one little planet with its perfect balance of air, pressure, and energy. So maybe it's okay that space is quiet. Maybe it's supposed to be. But still, if the stars could talk, what do you think they'd say?